Hello, I'm Miss Lake Battles, and today I'm here to talk to you about polar coordinates. Wait a minute, not polar bears. That would be silly. We're going to learn about polar coordinates on a grid, something like this one. If we were going to plot this red point in a rectangular coordinate system, we would need to know how far we went to the right for the x-coordinate and how far we went up for the y-coordinate. But polar coordinates really make great sense. We just want to know what direction we're going and how far we go in that direction. So the direction we're going is theta, and how far we go in that direction is given by r. So now we write polar coordinates in this form, r theta. Let's go back to rectangular coordinates. We're going to plot points in the rectangular coordinate system, sometimes called the Cartesian coordinate system. And to do that, we want to know how far to the right we're going to go. So let's just look at an example that's familiar. Let's say we're going 3 to the right and 4 up. That's the point 3, 4 in the rectangular coordinate system. Now, what if we wanted to know what the polar coordinates were? Polar coordinates, like I said, are given in the form r theta. So we want to know how far we went. So this would represent how far we went. And we also want to know at what angle we went that direction. So we're going to use our traditional angles, and we're going to use theta to represent that angle. So let's label the distance r. That is the distance. And then we already have theta labeled. That is our angle measure. Now for this specific example that I've chosen, let's figure out what r would be. Let's draw this in, this right angle. And if this was 3 and this was 4, now you see where I'm going here. This is this example I love. You can use the Pythagorean theorem, let's Pythagorize, or we can note that this is a 3, 4, 5 right triangle. So r is going to be 5. It's a 3, 4, 5 Pythagorean triple. So I know that r is 5. Now, I need to figure out what theta is. How do I figure out what theta is? Well, I do know what's opposite from theta and what's adjacent to theta. That's what was given originally. So let's use that. We know that tangent of an angle measure is opposite 4 over adjacent 3. So to find that value, we just need to find the inverse tangent. So we can find the angle using inverse tangent of 4/3. So let's put that in our calculators. Inverse tangent of 4/3. We're going to find that theta is about 53.13 degrees. So just make note, how accurate we need this. I'm just going to say it's about 53 degrees. So I've changed from rectangular coordinates, 3, 4, into polar coordinates, 5, 53 degrees. For some of our problems, we're going to use radian measures. Now, that was a great example, but now I want to look at it in a general sense, because we're going to need some way to change from rectangular to polar coordinates and also to change from polar to rectangular coordinates. So this time, instead of my specific example, I'm going to say that this is the point X, Y. That means this distance is X and this distance is Y. And remember, we're calling this length R. Now, this is our angle theta. So if we know X and Y, we want to be able to find R and theta. So the first thing I notice is the relationship between the sides of the right triangle. By the Pythagorean theorem, I know that R squared is equal to X squared plus Y squared. And for theta, I know that, just like we used before, tangent of theta equals, tangent is opposite over adjacent, which is y over x. So this general way of looking at it is going to help us change from rectangular to polar coordinates. Next, I want to be able to change from polar to rectangular coordinates, so I want to know what x and y are in terms of r and theta. So the first thing I notice here is I know what sine of theta is. I'm using my right triangle trig definitions. Remember, SOHCAHTOA. Sine is opposite over hypotenuse. So in this case, sine of theta is opposite, which is y, over hypotenuse, which is r. And since I want to solve this for y, if I multiply both sides by r, then I can have it in terms of y. Y will be equal to r sine theta. That's going to be very helpful and important for you to remember. Okay. Also, looking here, I see that cosine theta is adjacent over hypotenuse, which is x over r. So when I do the same thing here, multiply both sides by r so that I can solve for x, I get x equals r cosine theta. So these are going to be very important general formulas for you to remember. This is going to be helpful when we're changing from rectangular to polar coordinates, and then these will be helpful when we're changing from polar to rectangular coordinates. So I hope you have these in your notes. In the next video, we're going to work some examples. Woohoo! It has been a great day to learn pre-cal.